Example is delta of y all over delta of x or y subscript of x, etc. Now, identify whether an equation is linear or non-linear, homogeneous or non-homogeneous, the degree of the equation, order of an equation, whether the equation is autonomous or non-autonomous. Now, if you take a look at this equation, let's first of all know how to identify linear and non-linear differential equations. So, conditions for non-linear differential equations. The conditions for non-linear differential equations, whenever y is multiplying the order of the equation, whenever y is multiplying the order of the equation, that is y multiplying by y prime, whenever the coefficient of our derivative is y, that differential equation is not linear. Number two, whenever the highest order in a differential equation has 2 or more as the power, example dy over dx all squared, that equation is non-linear. Whenever the highest order in a differential equation has a power of 2 or more, then that equation is a non-linear differential equation. Then whenever you see y as the power, whether it's e raised to power y, e raised to power xy, etc., you know that equation is not linear equation. It is non-linear equation. Whenever you see something like sine y, cos y, tan y, etc., you know that that equation is non-linear differential equation. And here, to know the degree of an equation, the degree of an equation is the power. The degree of an equation is the power. This thing is a power, like dy over dx all raised to power 2. It means that this multiply by itself 2 times. This 2 is a power. So the degree of an equation is the power in which the highest order in a differential equation is raised to. The degree of an equation is the power in which the highest order in that equation, if you have first order in that equation, if you have second order is the highest order. The power in which the second order is raised to is the degree of that equation. Let's take examples here. If you want to find the degree of this equation, first of all, you need to find the order. Y prime is the first order. Y prime prime is the second order. Know that, I want you to know that y prime is the same thing as dy over dx. Y prime prime is the same thing as the squared y over ds squared. Y prime 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 is the same thing as d cube y over ds cube. Y prime prime, y prime prime prime, all these are called prime notations. Y prime prime, y prime prime prime, all these are called prime notations. Then dy over dx, the squared y over dx squared, the cube y over ds cube, all these are called the LEIBNIZ. Note that y prime is the same thing as dy over dx. Y prime prime is the same thing as the squared y over ds squared. Y prime 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 is the same thing as the cube y over ds cube. And y prime and dy over dx is first order differential equation. This is first order. Y prime prime and the squared y over ds squared are the second order of a differential equation. Then y prime prime and the cube y over ds cube are the third order of a differential equation. And also note that y prime is the same thing as dy over dx, y prime prime is the same thing as the squared y over ds squared, y prime prime is equals to the cube y over ds cube, and the order is, this is first order, the y over ds is first order, the squared y over ds squared is second order, the cube y over ds cube is third order. Y prime is the first order, y prime prime is the second order, y prime 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 is the third order. So if you look at this thing, y prime is here, y prime prime is there. This thing is the same thing as dy over dx, and it is first order. This one is y prime prime, which is the same thing as the squared y over ds squared. it is second order. This equation is the same thing as this: dy over dx minus the squared y over ds squared all squared is equals to 1. These equations are the same because y prime is the same thing as dy over dx. Y prime prime is the same thing as the squared y over ds squared. The same raised to power 2, the same raised to power equals to 1. So these two equations are the same thing. You can write it like this, or you can write it like this. It is still the same thing. So looking at this equation, to know the degree of this equation, is 2, because you first of all find the highest order in the equation. The highest order in this equation is the second order, which is y prime prime. The first order is y prime, is not the highest order, because y prime prime is the second and it is the highest order. And to find the degree, you check the power in which the highest order in the equation is raised to, and the power in which the highest order is raised to is 2. Therefore, you say the degree of this equation is 2. Then the degree of this equation is 2. Then if you want to check the degree of this equation, the degree of this equation is 1. The degree is 1. Since the degree is 1, see the highest order, to check the degree easily, you have to check what is the highest order in this equation. We have y prime prime, which is second order differential equation, and we also have y prime prime prime, which is third order differential equation. And this is the highest order, and it is raised to power of 1. So the degree of this equation number 2 is 1. Number 3, the degree is what? The degree is 1, because the highest order in the equation is y prime prime, which is the second order differential equation, and it is raised to power of 1. That 1 is spiritual, but it is raised to power of 1. Number 4, the degree of this equation is 1, because the highest order in this equation is y prime, which is the y over ds, and which is the first order differential equation, and it's the highest order. Therefore, it is raised to power 1. Therefore, it has a degree of 1. Number 5, it has a degree of 1 because y prime is the highest order. Number 6, it has a degree of 1 because y prime prime is the highest order. We have y prime, but it's not the highest order. It is the first order. We have y prime prime, which is the second order and the highest order. And it is raised to power of 1. Therefore, the degree of this equation of example number 6 is 1. Example number 7, the degree is 1. The degree is 1. Y prime 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 is the third order of the equation. It is the third order of the equation, and it is raised to power of 1. That one is spiritual, but it is raised to power of 1. So we say the degree of this number 7, the degree of the equation is 1. Example number 8, if you check the example of number 8, what will you say? Well, example number 8, the degree is 1 because the highest order is raised to power 1. The highest order is the second order, and the second order is the squared y over ds squared. It is the second order. But mind you, we have a first order here. This is the y over dx, all raised to power 2. The degree is not 2. The degree is 1 because the y over dx is the first order, and it's not the highest order in this equation. The highest order is the squared y over ds squared, and it is raised to power of 1. That one is spiritual. Therefore, we say the degree of this equation is 1. Example number 9. What is the degree of this equation? Well, the degree of this equation is 3. The degree is 3 because our highest order is the squared y over ds squared, which is the second order of the differential equation. The second order, and it is the highest order in this equation. We have first order here, we have first order here, but we have second order, and second order is the highest order. Therefore, we say the degree is the power in which the highest order is raised to, and 3 is the power in which this second order is raised to. Therefore, the degree of this example number 9 is 3. Number 10, The degree of this equation is what? The degree of this equation is 1 also, is 1, because the highest order in this equation is dy over dx, that is first order, and it is raised to power 1, and that one is spiritual. Therefore, the degree of this equation is 1. Please, if you don't understand, try to go back and start afresh so you understand well. We move over to identifying whether an equation is linear or non-linear. But let's revisit the conditions for non-linear equation. Conditions for non-linear differential equations are whenever y is multiplying y prime, that is whenever y is multiplying any of the order, whether it's first order, whether it's second order, whether it's third order, whether it's hundredth order, whenever y is multiplying an order of an equation, that whenever the coefficient of our derivative is y, that differential equation is not linear. Whenever the highest order in a differential equation has 2 or more as the power, example, the y over d, assuming that the y over ds, this is the first order and it is the highest order in the equation, and it has the power of 2, then we say that equation is non-linear differential equation. Then whenever you see y as the power, whether e raised to power y, e raised to power xy, whenever you see something like this, you know that it is non-linear differential equation. Whenever you see something like sin y, cos y, tan y, sec y, cot y, etc., you know it is non-linear differential equation. Okay, let's go back to our examples and identify whether which ones are linear and which ones are non-linear. Okay, from example number one, we say that this equation is non-linear. We say that it is non-linear because y prime prime is the highest order, and the highest order is raised to power of 2. And one of the conditions for non-linear differential equation is that whenever the highest order in a differential equation has 2 or more as the power, example, 2 or more as the power, whenever the highest order in that differential equation has 2 or more, like 2, 3, and above as the power, you know that equation is non-linear. That is what happened in this example number 1. The highest order in this equation is y prime prime, which is second order, and it is raised to power of 2. Therefore, we say that it is non-linear differential equation. Example number 2, we say that this equation is what? Is linear. Why did we say it is linear? Because first of all, check the highest order. What is the highest order in this equation? The highest order is y prime prime prime, which is the third order of the differential equation. Since this is the highest order, then what power is the highest order raised to? The highest order is raised to power of 1. That one is spiritual, but it is raised to power of 1. Since it is raised to power of 1, it is linear differential equation. But assuming that this y prime 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 is raised to power of 2, we will say it is non-linear. But since it is raised to power of 1, it is linear differential equation because y prime 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 is the highest order in the equation and it is raised to power of 1. Therefore, we say it is a linear differential equation. Therefore, a linear differential equation has 1 as the power of the highest order in the equation. So example number 3, we say that this equation is non-linear. Mind you, y prime prime is the highest order in the equation. Yes, we know. And it is raised to power of 1. So some may say, oh, it is non-linear. It is linear, sorry, because the highest order is y prime prime, which is second order differential equation, and it is raised to power of 1. Some will just see it and say it is linear. But mind you, this number 3 is non-linear because y is multiplying an order of an equation. Y it is multiplying y prime. Even if y is multiplying y prime prime or y prime prime, that is y is multiplying the y over dx. When y is multiplying the squared y over dx, the squared y is multiplying the cube y over dx cube. Whenever y is multiplying an order of a differential equation, that equation is non-linear. So the conditions, you say y prime, whenever the coefficient of our derivative is y, that the differential equation is non-linear. To example number 4, if you look at this equation, we say that it is non-linear differential equation. Reason because of this sign y. Remember, in the conditions, whenever you see something like sin 1 cos y tan y, it is, you know that it is non-linear differential equation. Then to here, number 5, whenever you see something like this, y prime plus 2xy equals to 0, you know that it is a linear differential equation. It is a linear differential equation because this is the highest order, y prime is the highest order, and it is the first order, and it is raised to power of 1. That one is spiritual. Therefore, we say it is a linear differential equation. To example number 6, we say that it is a linear differential equation. We say that it is a linear differential equation because the highest order in the equation is y prime prime, and it is the second order, and it is raised to power of 1. Therefore, we say it is a linear differential equation.